Today I have to discuss about generation of SSB signal. In this, SSB is nothing but when only one sideband, that is either LSB or USB, is transmitted, the modulation is refers to a single sideband modulations. In this, three methods are used to generate the SSB signal. First method is filter method, second one phase shift method, and third one reverse method. So here first two techniques are based on frequency domain, and third method, that is Weaver methods, are based on time domain. So here first frequency discrimination or filter method. This filter method can be used to generate the SSB signal. So in designing the band pass filter in the SSB modulation, it must satisfy two basic requirements. That is, first one, the baseband of the filter occupies the same frequency ranges as the spectrum of the desired SSB signal. And second one, the width of the transition band pass of filter separating the pass band from the stop band. So where the unwanted sideband of the filter input lies at twice the lower frequency component of the modulating signal. So this two basic requirements can be satisfy the generation of SSB signal. Next one, here the block diagram of frequency discrimination method. So first here it consists of band pass filter and multiplication. So in multiplication it consists of two input signal. First one modulating signal, that is M of t, and another input is carrier signal, that is AC cos 2 pi FCT. So these two signal can be multiplied by the multiplier and produce the output of DSB SC of t. So this output can be connected to the band pass filter. So the band pass filter, the function of band pass filter is it allows only certain frequency of the signal, and remaining signal can be rejected, that is eliminated, and produce the required output of SSB waveform. This is the block diagram of frequency discrimination method. In this block diagram, it consists of generate the SSB signal. It occupies the high frequency baseband signal. So it becomes very difficult to design the appropriate filter. So we have to move that next method. That is, in situation it is necessary to restore the multiple modulation process so as to filtering requirement. So thus next method can be used to generate the SSB. That is the next method, that block diagram of two-stage SSB modulation. So in this consists of band pass filter, two multiplier and two band pass filter. So first multiplier consists of two input signal, that is modulating signal M of t and carrier signal A1 cos of 2 pi F1 of t. So these two signal can be multiplied by multiplier and produce the output of V1 of t. So this V1 of t is connected to the input of band pass filter. So we already said that band pass filter can be used to allow certain frequency of the signal and produce the required output S1 of t. So this S1 of t is connected to the input of this multiplier. So this also consists of two input, S1 of t and the carrier signal A2 cos 2 pi F2 of t, and this multiplier produce the output of V2 of t. So this output V2 of t is connected to the input of next band pass filter. So the band pass filter reject the unwanted signal and produce the required output of S2 of t. So this is the generation of SSB signal by using the frequency discrimination method. So in first stage it consists of only one multiplier and band pass filter. This first stage that required the high frequency, so this is very difficult to design the filter and produce the sideband signal. So then we go for next method, that is two-stage SSB modulator. So in this two-stage, modulating signal M of t and carrier signal is multiplied by using the multiplier and produce the output V1 of t. So this V1 of t is connected to the band pass filter. So the band pass filter produce the output of S1 of t and it will be connected to the another multiplier. So this multiplier can be used to multiply this S1 of t and carrier signal and produce the output of V2 of t. So this V2 of t is connected to the input of band pass filter and produce the output of S2 of t. So this is the first frequency method can be used to generate the SSB signal. Next method, phase discrimination method or phase shift method. So this is the block diagram of phase shift method. So in this block consists of two product modulator A and product modulator B. So first product modulator A consists of the input modulated wave and another input comes from oscillator. So the output of oscillator is carrier signal. So this two signal can be multiplied by using the product modulator and produce the output. So in this phase discrimination consists of two paths. One is in phase path, next one quadrature path. So here the product modulator A output produce the output in it is the in phase path. So it will be connected to the summation point. And the next, the product modulator B consists of two input. One is the modulated wave, but this modulated wave consists of 90-degree wideband 90-degree phase shifter and produce the wideband output is m cap of t. It will be connected to the product modulator B. Another one input is oscillator, produce the output the carrier signal. This will be 90-degree phase shift and it will be connected to the product modulator B. So this will be connected to the summation point, and after the quadrature path, this produce the output of S of t. So this is the phase discrimination method for generate the SSB signal. So here in phase discrimination method, it also called as Hartley modulator. So it consists of two parallel paths, that is the in phase path and quadrature path. So each path involves the product modulator. So these two product modulator consist of two input signal, that is modulating signal and carrier signal. Modulating signal and carrier signal here in this phase discrimination consists of Hilbert transform, can be used to generate the SSB signal. Next one, so here the degree to which the unwanted sideband may be suppressed depends upon the following factors. What are the following factors means? First one, balancing accuracy of the product modulator. So the product modulator, the accuracy of the balancing modulator is one of the factor to eliminate the unwanted sideband. Next one, control accuracy of the quadrature phase relationship of the two carrier signal. Third one, errors in the approximation of the constant phase difference between m of t and m cap of t. So these factors can be used to that is suppress the sideband signal. Depends upon these following factors can be used to eliminate the sideband signal, that is unwanted sideband signal. So here generation of SSB signal using pair of phase shift network. This is the block diagram. So here this generation of SSB signal using a pair of phase shifting network to realize a constant 90-degree phase difference. So this is the block diagram. So here the product modulator A and product modulator B. This will be consist of two input. So the product modulator A consists of alpha network and product modulator B consists of beta network. This will be consist of modulating wave m of t is given to the input of both alpha network and beta network. So the output of alpha network and beta network connected to the product modulator A and B. So this also consists of another input is oscillator. This output of oscillator is the carrier signal, that is AC cos 2 pi FCT is connected to the product modulator A. The another is connected to the with 90-degree phase shift. So this carrier signal with 90-degree phase shift, that is AC sin 2 pi FCT is connected to the product modulator B. So this product modulator output of product modulator A and product modulator B is connected to the summation point plus or minus. So depends upon this will be produce the output of SSB. So this is the generation of SSB using the pair of phase discrimination method. So next one, Weaver's method or third method. So in this third method was developed by Weaver to it is overcome the drawback of phase shift method. So that is, if any drawbacks available in the phase shift method, means it can be used to eliminate by using this Weaver's method. So the disadvantages of phase shift method means it is produce 90-degree phase shift network for modulating signal is extremely critical. So this is one of the phase shift method drawbacks. So this Weaver method can be used to overcome this disadvantages of phase shift method. So here the third method, that is the block diagram. So this is the third method, block diagram of generation of SSB using the third method or Weaver's method. So in this block consists of low pass filter and modulator, 4 modulator, that is balance modulator M1, M2, M3 and M4. This 4 balance modulator also consists of modulating input and carrier input. So this first one, the modulator, balance modulator M1. It consists of 2 input, that is AF audio input and the carrier signal with 90-degree phase shift. So this 2 signal can be modulated and produce the output. It is connected to the low pass filter. So the function of low pass filter, it allows only low frequency signal and reject the unwanted signal. So in this, the product modulator M1 and M3, it is connected to the input of AF input, that is audio frequency input and carrier signal with 90-degree phase shift. So first balance modulator consists of 90-degree phase shift carrier signal and audio input. This 2 signal can be multiplied and produce the output. It is connected to the low pass filter. Next one, balance modulator 3 and produce the output. It consists of 2 input, that is AF input and carrier input without phase shifter. So this 2 signal can be multiplied and produce the output. It is connected to the low pass filter. So this 2 low pass filter produce the low frequency signal and connected to the balance modulator 2 and 4. So in this, balance modulator 2 consists of 90-degree phase shift carrier signal and balance modulator M4 consists of without 90-degree phase shift carrier signal. So this produce the output and will be this both the modulator output M2 and M4 connected to the adder. So adder can be adding this 2 signal and produce the SSB signal. This is the generation of SSB signal by using the Weaver method or third method. Here the AF audio frequency safe network to operate over a large range of audio frequency. So in this, advantage of phase shift method such a ability to generate single sideband signal at any frequency and use low audio frequencies. So this is the required generation of SSB signal. So SSB generation consists of 3 methods. First one is frequency discrimination method, second one phase discrimination method, and third one is Weaver method. So based on this method can be used to generate the SSB signal.